Here I am doing standard number 4, which is beats and Doppler, chapter 16, number 71. The problem says, a man marries a great Wagnerian soprano, but alas, he discovers he cannot stand Wagnerian opera. In order to save his eardrums, the unhappy man decides he must silence his lark-like wife for good. His plan is to tie her to the front of his car and send car and soprano speeding towards a brick wall. This soprano is quite shrewd, however, having studied physics in her student days at the music conservatory. She realizes that this wall has a resonant frequency of 600 hertz, which means that if a continuous sound wave of this frequency hits the wall, it will fall down, and she will be saved to sing more. I don't even know what that says. The car is heading towards the wall at a high speed of 30 meters per second. A. At what frequency must the soprano sing so that the wall will crumble? Here we use the equation. The frequency of the listener equals the speed plus the speed of the listener over the speed plus the speed of the source times the frequency of the source. So we have 600 hertz, which is the frequency of the wall, the listener, and then we have the speed of sound, 344 divided by, plus the velocity of the listener, which is 0, over the speed of sound, and it would be minus 30, because this would be negative, times what we're looking for, the frequency of the source, and if you compute that, it equals 548 hertz. The second part, B, what frequency will the soprano hear reflected from the wall just before it crumbles? So here, the velocity of the source equals 0. The velocity of the listener equals a positive 30 meters per second, unlike the negative up here. Or that was the source, not the listener anyways. And then the frequency is the same. So we are solving for the listener this time instead of the source, and we get 652 hertz.